Okay, welcome to InnerSource Summit in NYC and to the IBM office here. For those of you who have been around for a while, you might have seen me before. A few years ago, I came to InnerSource Summit and gave a talk about our work on Watson NLP, our InnerSource natural language processing stack that was the talk of the company in the pre-generative AI era. Of course, since that time, so much has changed. As we all know, generative AI burst onto the scene not long after that talk, forcing us all to question whether our work is going to be supplanted by machines. The story we're hearing in the media is that AI is going to outcode us all, that the biggest benefits to our productivity come not from working with other people, but from simply creating massive amounts of code. Today, we live in a world where anyone can pop open Cursor, Replit, or Claude code, type a few short sentences, and be off to the races, creating new libraries and apps. If AI can produce so much code so easily, then what value is there to focusing on so much on human systems of code collaboration, as we do in the InnerSource community? I think most of us who come here to InnerSource Commons have this deeply held instinct that great software products come from great code. And great code is a result of creating dynamic, collaborative systems between humans that make it possible to polish gems of code and bring them into existence. So I want to tell you a story about AI, about communities, and about how careful collaboration is critical to the success path, whether you're using or building AI. My name is Olivia Buzek. I've been building AI for a long time. Back when I was first learning to program, which was more years ago than I can count, all I wanted was to build a little app that would sit in the corner of my computer, keep track of what I was doing, and send me little notifications. I could talk to it and ask it to do things like keep me on task and build out my schedules and to-do lists, ask it to play music for me and help make sense of my notes. That desire to talk to my computer in words and make it talk back is what brought me to AI in the first place. I studied computer science and linguistics while I was in school, and in the process, I learned just how similar the structures are that underlie how we communicate with each other and how we communicate with computers. At the time, that mostly meant realizing that the syntax of code can be represented with the same sorts of theoretical structures used to represent natural language sentences, which meant that we could do things like this. If you didn't know, you can use a context-free grammar both to interpret code as well as human language. In English, we break things down in noun phrases and verb phrases. In code, we break things down in statements and expressions, but they both adhere to the same recursive structures, making it a really natural thing to pull the things together. I started at IBM around 10 years ago when I joined a little team called Alchemy API, which had just been acquired by IBM. I joined as a machine learning engineer. My job was to build out natural language processing software. We built a product called Natural Language Understanding, which was a collection of APIs that could return linguistic analyses like this one. The main functions it offered were sentiment detection, named entity recognition, and classification. Being able to build technology like that was incredibly cool, but it was still really opaque to a lot of people. It took a lot of specialized knowledge to recognize that you could use tools like sentiment detection and named entity extraction to accomplish useful and important tasks. For this reason, in that era of AI and machine learning, it didn't get a lot of uptake among developers on its own. The machine learning tasks that landed with people were ones that solved real use cases that companies had. We excelled at selling early chat assistant systems, building systems that helped extract insights from large amounts of documents, and building and training classifier systems. Selling NLP tools on their own didn't really land in the market, but the basic NLP tools were essential to solving all of those use cases. Around the same time as we at Watson were building out all of these machine learning and natural language processing services, a paper came out from Google. It was called Hidden Technical Debt in Machine Learning Systems. The entire paper is worth a read if you haven't heard of it, but I want to focus in on this one diagram. So this is an abstract representation of an average machine learning system, even before the current generative AI era. This was published about 10 years ago. See how the machine learning code only takes up about like 5 to 10% of a typical system? The rest of it is actually a whole bunch of software engineering. A complete machine learning system isn't just a model. It's not just machine learning code. It's data management, it's pipelines, it's resource management and monitoring. If you use generative AI today, the nature of these complex systems gets obscured. We talk a lot about which models do people use, when really we're using Claude, Gemini, ChatGPT. And when you're doing that, you're not just talking to a model. You're actually talking to an agent system, a series of microservices supplying memory with underlying databases, hosting for a base model, and sometimes fine-tuned models, as well as management of prompts and coordination of tools so that the agent system has access to the world. In these early days, we saw a lot of need for reuse. In the machine learning code, yes, especially since that required highly skilled machine learning engineers that were absolutely scarce on the ground. But we also needed reuse in the types of serving infrastructure that were relevant to building machine learning systems. With systems this large and complex and so many shared architectural chunks, we knew we had to focus our efforts on sharing our NLP technology internally. So we started on our InnerSource AI journey, bringing the very best of IBM's NLP tools to the rest of the company so that our best NLP technology could succeed. We created a library called Watson NLP, meant to share natural language processing basics across all of our major products using an InnerSource process. IBM has played in InnerSource and open source for decades, but as many of you might know or expect, it's always been confined to one part of the company or another. It's never been a ubiquitous practice. Outside of those areas of collaboration, there's a walled garden, only navigable if you have a deep understanding of how to network within the company. Our early approach to AI was no different. When we came to build Watson NLP, there was no shortage of brilliant, innovative NLP technology around the company. The question was finding it, bringing it together, and making people actually want to use it. We encountered all the usual obstacles that teams tend to face when creating InnerSource software. But at least for the time, Watson NLP prevailed and became a common stack among several products in the company. Then, in 2017, came the seminal paper, Attention is All You Need, which introduced us all to transformer models. If you don't know, transformer models are really what underlies the LLM revolution we have today. At first, we simply developed small transformer models, which were useful in supporting the functions we already offered in our library. But in 2020 and 2021, the GPT series was released, ChatGPT hit the scene, and since then, the zeitgeist has taken off. Suddenly, that dream that I had that brought me to AI in the first place, it wasn't science fiction anymore, but something that I could actually build in reality. As foundation models broke onto the scene, our lives as NLP engineers at IBM shifted under our feet. The library we'd built was no longer relevant. We'd worked so hard to InnerSource it. It didn't really matter anymore. But as we'd come to learn, everything we'd learned about building machine learning systems and InnerSourcing them absolutely was. The architectures that support machine learning models now are even more complex. Not only do you have all the hosting and learning infrastructure from the earlier era, but we also need to account for new orchestration needs, authentication management, memory management, prompt management, and more. Here's the thing about AI systems, though, that has been the secret to IBM's position in this space. We look at them as a normal technology. So what do we mean by that? The concept comes from a recent paper from Arvind Narayanan and Sayesh Kapoor. As they say, to view AI as normal is not to understate its impact. Even transformative, general purpose technologies such as electricity and the internet are normal in our conception. But this is to build a contrast against utopian and dystopian visions of the future, which have a common tendency to treat it akin to a separate species, a highly autonomous, potentially super intelligent entity that's out to replace all of us. I recommend reading their work to anyone who's curious about the concept of normal technology, especially with the amount of hype that we all see every day. They talk about what it looks like to discard the concept of AI as a super intelligent agent that's capable of improving itself. They discuss their expectations that changes into society from generative AI is likely to be constrained by safety, and fundamentally, that AI technology adoption is limited by how fast human organizations and institutions choose to pick it up. In other words, the same sorts of InnerSource practices that we talk about here. And they talk about what mitigation of AI's real world impacts look like under this worldview. As IBMers who went through the early Watson era, we share this insight at our core. And that means that even AI systems are simply very complex software engineering. So everything we already know about how to build great software remains true, including that it's best served by reuse of critical components shared in an InnerSource framework. I'm going to back up for a minute. People who've been around in the technology world for a while know that IBM was actually one of the first companies to bring AI to market. When Watson first came around, its main claim to fame was winning at Jeopardy! After that, we pivoted into expert systems. We started by targeting medical use cases. Watson was supposed to outdiagnose doctors. We learned very quickly that doctors did not want to be outdiagnosed. They did not want to be replaced. For the simple diagnostics, they didn't need an expert system for this. It's easy enough for a doctor to diagnose a cold. And for the more complex ones, the machine learning system wasn't really good enough, and human intervention was necessary. Adding in a machine learning system in those cases simply caused frustration among the doctors. Watson's Jeopardy! Win didn't usher in an era in which human knowledge was obsolete. It was a fascinating demonstration, but changing society is a much deeper and more complex exercise. And as we discovered when we tried to offer those expert systems to doctors, if you want AI to work with humans, you need to show up in ways that support their work as they wish to be supported. What our leaders realized is that we needed to invest in AI as though it is a normal technology. There will always be money to be made by being especially good at putting pieces of technology together, especially when actually helping people with AI technology is this complex. And that means that we have nothing to lose and everything to gain from taking an open core approach to our AI. The last time I was at InnerSource Summit, I came to tell the story of Watson NLP. The story I told then was about our little Python and Java library that had packed into it the most important work in IBM's natural language processing space. There were several key InnerSource insights that we had at the time which helped Watson NLP succeed. First, the InnerSource catalyst. InnerSource doesn't just happen. It requires specific conditions. We had redundant development happening across teams with everyone building their own NLP solutions. We were working in a bleeding edge area where constant change meant centralization could help everyone share important innovations. We had the collaboration infrastructure, GitHub and Slack, to make it possible. And critically, we had leadership willing to buy in, willing to give up some predictability in favor of cohesion. Second, our goal was to make something that looked like it was written by a hive mind. Early on in our development process, we asked several machine learning engineers at IBM what it would take for them to rely on a library written by another team in their stack. They told us continuous updates, modern and intuitive UX, flexibility for experimentation, reliability, extensive and clear documentation, friendly licensing, production readiness, and that intangible hive mind feel. Sounds a lot like InnerSource. That feeling that comes from many smart people working together, iterating, polishing, and sharing standards. In practice, it looks like remarkable consistency in code style, amount of tests, organization of the code, and API surface, both internally and consistent with the rest of the practices across the industry. We realized that if we wanted our internal tools to compete, they needed to feel like they were built by a hive mind too. And third, we needed a clear path to growth. The concentric circles of our community, from Watson products at the center to the larger IBM NLP community, to anyone building an AI at IBM, meant there was a clear path to benefiting larger and larger groups, giving us a path to new contributors and new maintainers. We weren't just building a library, we were building an internal community around NLP and AI. Because it was something we were uniquely good at, there was good reason for other teams to pick up our library over either rolling their own or picking up something off the shelf from open source, which was very common at the time. And while we never quite achieved enterprise AI ubiquity with Watson NLP, it set us looking in the right direction towards the larger community of anyone, anywhere, building enterprise AI. When the generative AI era came, the way we built machine learning systems had to change. Their models were much, much bigger and could no longer be reliably loaded on a single CPU or GPU. Complete model training was no longer something we could offer to users through a SaaS service. It now takes months to train a single foundation model. Foundation models supplanted custom trained models for things like sentiment detection, named entity extraction, and relationship extraction, replacing a lot of the basic functions that Watson NLP offered. And even functions like summarization, which was suddenly solved in the generative AI era, no longer wanted the same form factor of submitting a document and expecting a single paragraph back. So the library we'd built and much of the infrastructure around it had to change. But even though we were facing new architectural and engineering challenges, the core collaborative insights remained. When I revisit this talk, what I'm fascinated to see is that while we no longer use that particular library in much of our stack, there's still salience to much of what's there. The stories we told then have become amplified throughout the company, to the point that even though that particular asset didn't survive, the mentalities we built then have. During the Watson NLP era, we engaged in a lot of the sort of internal politicking that I imagine is familiar to many of the people here. We spent a good bit of time convincing executives that it was worth their time to add new maintainers to our product. We talked to architects to persuade them that rebasing on our stack would help us all grow together. We worked with code creators who were frustrated that they had to change their coding style to add contributions to a cohesive whole. We made headway with some people and less with others. Then, just as the groundswell of generative AI was beginning, several critical puzzle pieces shifted into place. Several aligned people moved into leadership. A new CEO took over and signaled to all of us that he was going to prioritize more open source-like practices when he led the acquisition of Red Hat. The director of IBM Research declared to all its workers that going forward, output in the form of InnerSource and open source assets would be expected as part of your job. Under that aligned leadership, Watson NLP was expanded into Watson Core, intended to bring to the rest of machine learning infrastructure the reuse lessons we learned with Watson NLP. An internal InnerSource program office was created, and we kicked an InnerSource portal off the ground. And the Academy of Technology, a long-standing internal community of practice in IBM, was transformed into the open innovation community, where people were encouraged and invited to work together on important strategic initiatives for the company and contribute the output as InnerSource assets for other teams to use. There's an entire story there, but it isn't mine to tell. Do keep an eye out for Michaela and Jenna's talk after this, though. All of those moves were great things, and yet small in the scheme of things. Watson NLP still hadn't achieved the complete adoption that we'd hoped. In fact, it was starting to be starved of resources as priorities shifted elsewhere, much as all of your attention has to this delightful thing here. So many of the people we spoke to on the ground said that it seemed to them that InnerSource had failed. Our successor project, Watson Core, couldn't quite find its footing and ended up mostly building the back end for another one of our product teams. Anti-patterns started to emerge. Yet still, I call this a success. Why? Because not long after Watson NLP's heyday, when generative AI really hits its stride at the end of 2022, we were ready. Our research group kicked off two complementary efforts, building our own trusted LLM family of models that would be trustworthy enough to work in enterprises, and building a shared internal playground platform where everyone could kick the tires on both those models and other models coming from other companies. One group was used to working in a closed way and needed a push from our central InnerSource team to help them open up, to make building possible. The other group came from a startup mentality and opened themselves up by default and failed fast in public internally. These two groups built on the successful cultural transformation internally to gain visibility and coordination between teams in the company. And eventually, that work resulted in Granite. The Granite family of models was released a couple of years ago. It's on version 4 now, which introduces a new architecture that performs even better than the metrics here. I really love Granite. I spend a lot of time talking about Granite, and it's because we've put an enormous amount of work into making sure it is a small, energy efficient, trusted model out in the wild. It's specifically designed to perform well at small parameter sizes. It's trained on 95% open data, performs quite high, if not better than the rest on many of the general benchmarks, and it's ready for enterprise tasks. When we created Granite, we made a big move. We would move beyond inner sourcing Granite, pushing our model family out into the world on Hugging Face and the Olivia registry under an Apache 2.0 license. Nearly every large AI company has done this at this point, but when we made this decision, we were among the earliest of the large companies to make this choice. Granite, our family of small language models, came from understanding something only IBM could know, that enterprises need models. Yes. Normal operation, fantastic. All right. Okay. Enterprises need models that are particularly good with documents and tool calling, even on small hardware. That's decades of document processing and expertise distilled into models that can run on incredibly diverse hardware. With the recent model version, our Granite 4 family, punching above its weight even when running on a Raspberry Pi. The decision to open source Granite was a risky one, but in retrospect, it was the only way to go. Our first models were good at certain tasks, but not quite competitive with the hosted models from other companies. As the external industry model space expanded, though, our years of experience in AI, now boosted by InnerSource collaboration, started to really shine in the places where we had that particular expertise. We could only prove that our AI was worth its salt by making it incredibly easy for people to access and play with. And making that choice to open source Granite also opened the doors for several other AI components to thrive in the space. Docling, our document understanding library, is the one that really shows this position of strength principle in action. It has 43,000 stars on GitHub now. It came from an InnerSource project we used to call Watson Document Understanding, but it's evolved for the generative AI era. This represents decades worth of work, and we open sourced it. Why? Because it's a critical piece of technology. It takes a complex system to make it truly effective in the types of enterprise use cases we're targeting. We share Docling in hopes that the whole industry might benefit, but also so that we're certain when IBMers are building out applications and they turn to the best of open source, our own technology is in consideration. Placing Docling in the open sets a high bar for what to expect when it comes to IBM technology. Docling delivers best-in-class functionality, and the repository is built to give off all the signals of an active open source community. Langflow came from our DataStax acquisition, but we folded it right into our collaborative work. It's an open source, low, no-code agent system design framework. This bit of software helps address one of IBM's Achilles heels over the years. It's often hard to get started with enterprise-level products. Langflow lets you walk right in and get going. Context Forge and the BAI platform are newer. They're tackling the orchestration challenges that come with the agent era. Context Forge gives you a clean, secure endpoint for managing MCP servers, the dominant protocol that emerged this year for agent systems to talk to other services. BAI platform is an open source platform built on the agent communication protocol, which we're now working to merge with A2A, making it easy to discover, run, and orchestrate agents built with different frameworks. This project we recently donated to the Linux Foundation. Both are still finding their footing, but they represent something important. IBM is building all of the necessary pieces that make AI systems work together. And we're choosing to offer them in open source, knowing that by doing so, we're representing to both ourselves and the world that we've built technology that we believe in. Once our leaders had recognized that open collaborative practices were the only way we could regain lost ground in AI, it almost didn't matter whether we used InnerSource or open source collaborative practices. We needed a way to ensure that we were using the best components available to us in our own work, that we were organizing our best insights into modular components, and that anyone with great ideas had a way to contribute. If you're at a company where you're trying to make this case, you've probably run into all the objections we did. Sharing code and assets will let other teams steal credit. Open sourcing core components will let competitors outcompete us. Our work is too sensitive to share. Collaboration will just mean other teams stealing my team's time. Huh? Yes, it's correct. Here's what we learned. Participating in InnerSource and open source both is a statement of strength and a belief that the company has more to offer when we work together than when we offer a disjointed collection of work. InnerSource has its roots in open source. Even in our early days, we compared ourselves to the best of open source when we were choosing what to build. The Watson NLP library looked at Spacey, Hugging Face, and NLTK, the best AI libraries of the day. Now, our best InnerSource offerings are also our best open source offerings. And the way we make sure that they're the best is by comparing to the best in the outside world. Taking that risk, choosing to put some of our best technology outside of the company, free for the taking, meant potentially losing customers who might take what we had and build it themselves. But it turned on a major signal for our internal developers that we're no longer satisfied with just better than the rest of IBM. We're actually only satisfied when our technology is truly the best of what's around. InnerSource alone was not enough. InnerSource created the conditions for open source. And then open source created a virtuous cycle where InnerSource can now thrive. What you see here are the survivors. Many AI projects have been born in the last few years, many have failed. The internal playground I mentioned is long gone, replaced by an external facing paid product. But you see in each of these InnerSource and open source successes, the elements of the InnerSource catalyst. Redundant work across teams that needed centralization, bleeding edge technology, where collaboration helps everyone, and leadership willing to invest in cohesion over predictability. The technological needs of generative AI created the conditions that made InnerSourcing and then open sourcing the components into the obvious choice for the company. Human innovation, things that can transcend what one person can do alone, requires collaborative practices like InnerSource and open source in order to be effective. So that's the story of why we needed InnerSource to build AI, which was absolutely necessary at IBM. But for many of you here, it's the existence of AI that seems like a bigger threat to your InnerSource work. Here we go back to our initial question. If AI can produce so much code so easily, what value is there to focusing so much on human systems of code collaboration as we do in the InnerSource community? Do we even need human collaboration strategies in the age of AI? So I'll pull this back all together and make the case for why this matters, not just for IBM, but for anybody building technology in the age of AI. Let's go back to what we said before. AI is a normal technology. It is a complex system, not a superintelligence. InnerSource and open source both, as a collection of practices, is about building systems that through a process of iteration builds assets that exceed our individual intelligence. InnerSource practices recognize that our collective intelligence can build better, stronger, more effective systems than any of us could build alone. Interestingly enough, AI relies on this same insight, but because of its probabilistic nature and because of the lack of superintelligence or consciousness, what AI produces will tend to regress towards the average of what humans have already produced in the past. You see this again and again. To date, while specially trained AI systems have sped up certain lines of scientific investigation, generative AI has not been able to create anything novel on its own that stands up to critical human scrutiny. AI is capable of speeding us up at tasks that the average human expert can do in their sleep, but still struggles when attempting to exhibit novel, sensible behavior at the outer edge of the expert's problem space. This is as true today as it was during IBM Watson's medical diagnosis area, when we learned that the doctors didn't need help with simple cases and our systems weren't quite good enough for the complex ones. Improving AI systems, as with other types of software engineering, requires reconceptualizing architectures, identifying new training paradigms, and navigating fundamental trade-offs, tasks that require the kind of open-ended reasoning AI currently lacks and may always lack. What AI is fantastic at, though, is helping us with recombination, reprioritization, pattern matching, and iteration. Whether you are using AI or building AI, you'll find that bringing AI into the process of evaluation, data synthesis, log analysis, prototyping, and re-architecting may help yield some new insights. But when it comes to deciding what to do with that information, that's going to take a human touch. And here's where InnerSource becomes essential. The very complexity that makes AI systems challenging to build is exactly the kind of complexity that InnerSource practices were designed to address. When you're navigating architectural trade-offs, managing interdependencies, and coordinating across teams to build something that no single person could create alone, that's when collaborative development practices matter most. Ultimately, in IBM's AI InnerSource story, it was human ingenuity that prevailed. No LLM could have guided us to create Granite or Dockling. Humans have had to make the critical choices along the way. LLMs will always limit us to the best of the past. To build something truly novel, including AI itself, it requires human collaboration and human ingenuity. And for that, we need InnerSource. So when I hear people say that AI is going to outcode us all, that our jobs are at risk, that collaboration doesn't matter anymore, they're missing a key point. The very nature of AI as a normal, complex technology means we need human collaboration more than ever, not less. Whether the current narratives in the media around AI survive, this I'm confident about. AI systems are normal. AI systems will always continue to be complex and will always need the human systems around them to truly be successful. Today, you're going to hear a lot of stories that echo these same insights about the human infrastructure that makes building with AI possible, about what one does when people are vibe coding their contributions to your central components, and about how cultural practices around collaboration are essential to success. Building software in the age of AI has never been more human. Thank you.